Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Today we're going to be starting up the material for Meet 4 of IMLEM. Now for those of you new to this channel or new to this video series, or IMLEM, I'm just going to break down how IMLEM works. So here are the structure and categories of IMLEM. So in IMLEM there are 5 competitions total, and each competition tests different material. Now today we're going to be talking about material specifically from the 4th competition, which we call Meet 4. Now, inside every competition, there are 5 different categories, which are mystery, geometry, number theory, arithmetic, and algebra. And for each of those categories, we assign each of them a number 1 through 5, with mystery being 1, geometry being 2, number theory being 3, and so on, as you can see in the list I have on the screen. Now, the way I'll be labeling my videos is something like this. So this video will be labeled 4.2.1, for example, where the 4 represents the competition number, as in Meet 4. The next number, the 2, represents the category, which means we're talking about geometry, because as you can see over here, geometry is number 2. And then the last one, the 1 here, is just the section of the geometry, just to help break things down and a little bit for organization. So, as I was saying, the first category inside Meet 4 that I can teach you is geometry. So let's get right into it. So geometry Meet 4 has a lot to do with circles. So I'm going to be explaining a few terms we use with circles and what circles are right now. So first, a circle is a set of all points equidistant from one point, which is called the center of the circle. So if that was a little bit confusing, I have an example here. As you can see, I have 5 points here drawn out, with one of them in the center. Imagine this is the center of our circle. The circle definition is the set of all points equidistant from that one point. So all 4 of these points are the same distance from the center. And if I were to draw a line connecting them, making sure that all the points that are on this line are the same distance from the center, that's what gives me the circle. So I know the circle is probably something that you've encountered before, but just for the technical definition, if you take the center of the circle and you find the distance from the center to the edge, no matter where you do that, and that's what we call the radius, so no matter where you do that, it will always be the same. So this distance will be the same as this distance, for example. Okay, so next is the radius, which I just mentioned. So the radius is just the distance from the center of the circle to the edge, which I have here, and I labeled them both R. And it doesn't really matter where on the edge, because remember, the edge will always be the same distance away from the center. So anywhere, it's just the distance from the center to the edge. Next is the diameter. So diameter is very similar to radius, except it's not just from the center to the edge. It's from the edge to the edge, and it has to go through the center. So basically, if I were to draw a line going straight through the circle, like this, oops, that was a bad line, like that, this would be the diameter, which we label with a capital D. The diameter is always going to be twice the radius, because if you think about it, here's one radius here, going from the edge of the circle to the center, and here's another radius here. It's just the distance across the circle through the center of the circle. And then finally, the last term you need to know that's special about circles is the circumference. So the circumference is the distance around the outside of the circle. Now, for most other shapes, we use the word perimeter to describe the distance around the outside of that shape, but we have a special term for the perimeter of a circle, which we call a circumference. And now one last term I didn't add here because it stays the same is area, but just in case you didn't know, area is the amount of space inside the circle. All right, so we just talked a little bit about circumference and area, but in Meet 4, you're actually going to have to be able to find the circumference and area of circles. Now you do get a calculator, which will be very helpful because when you find the circumference and area of circles, you're going to be working with decimals. All right, so let's first talk about the circumference of a circle, which remember is the distance around the edge. So the circumference, we have 2 different formulas for it. They both equal the same thing, obviously, is 2 pi r or pi d. So let's break down this formula a little bit. So the first thing that we haven't talked about yet is this pi here. That's this symbol right here that kind of looks like a table. It's in both of these formulas here. Now pi is essential when it comes to circles. And pi is what we call a constant, which means it's just equal to some number. So this is the value of pi, or it's about the approximate value of pi. So pi is about equal to 3.141. Now you may be wondering why we don't tell you what pi is actually equal to. And that's because we can't. So see, pi is what we call an irrational number, which means it's a number that goes on forever without any patterns. So we can't represent it as a fraction, the decimal never ends, and it doesn't have any patterns, so we can shorten the decimal, which is why we can only say it's about equal to 3.141. But for those of you curious, it's about 3.1415926535. And you see where I'm going with this. The digits go on forever, which is why we have an about equal to sign here. So when you use pi in most questions, you're not going to have to use more decimals than these three. And in some questions, they'll actually just say, oh, use pi as 3.1 or use pi as 3.14. And your calculator also has a pi button on it, which will be pretty accurate in terms of the value of pi. So pi is just a constant. So say we're going to do a practice question where we found the circumference of a circle with a diameter of 4 centimeters, right? Because this question says, if the diameter of a circle is 4 centimeters, find the circumference. Well, I'm actually going to label that here. Remember, diameter is the distance across going through the center. So this is the diameter, and this is 4 centimeters. So let's use our circumference formula. Our circumference is going to be pi, which is 3.141, and I'm just going to use 3.14 in this case because I don't want to have to write it out all of it. And sometimes they'll let you use 3.14 and you won't have to use 3.141. So the circumference is 3.14, or pi, times 4, which is our diameter. So 3.14 times 4 is going to be equal to 12.56. All right, so we'll write that here. It's equal to 12.56. So that's going to be the circumference of this circle. Now we also have another formula, which is 2 pi r. And the reason that we have two formulas is because they're actually the same, but you can think about circumference in terms of the radius of the circle or the diameter. Because remember, the radius is the distance from the center of the circle to the edge. And since the diameter is the distance across, then the radius is always going to be half the diameter. So therefore, if you have 2 times the radius, then that's equal to the diameter, which is why 2 times pi times the radius is equal to just pi times the diameter. So you can use either of those formulas. All right, so next we're going to be talking about how to find the area of a circle. So the area of a circle is A equals pi r squared. So this is why we have both radius and diameter, because it's easier to use diameter in the circumference formula, but in the area formula, you have to use the radius. So we have pi, which remember is just 3.14 times r squared, which means whatever value of the radius you have to square that, which means multiply it by itself. So let's do a practice question. So this question asks us to find the area of a circle if the diameter is 4 centimeters. So it's actually the same question we had up here, except now we just have to find the area. So we know the diameter is 4 centimeters. So the radius of this circle, because we need the radius in order to find the area, is going to be half the diameter, because the radius is always half the length of the diameter in a circle. So if our diameter is 4, then our radius is going to be 2. All right, so now our formula is area, which is A, equals pi, which I'm not going to write out the number, times 2, which is a radius, squared. So A equals pi times 2 squared. All right, so I can simplify this a little. The area is going to be equal to pi times 4, because 2 squared is 2 times 2, which is 4. And so the area of this circle is going to be pi times 4, which we actually did up here. And that's going to be 12.56 centimeters squared. And so this is the only, in case you're wondering, this is the only type of circle that actually has the area and circumference as the exact same. One that has a diameter of 4 centimeters. But in all other cases, your diameter and your circumference and your area will be different in the circle. All right, and now I'm just going to try to explain why the area of a circle is pi times r squared. So this might get a little bit confusing, but I have a picture just to help describe it. So here we have a picture of a circle, which is broken up into a bunch of parts, right? We divided it equally into a bunch of different parts, which are tan and blue, and we arranged them in a way so they kind of make a square. So the area of the square, right? So area, the area of a square is always going to be the length times the width of the square. So if we think about it, the length times the width, or we could also say base times height, is going to be, in this rectangle, r times pi r. And here's the reason why. So first, let's talk about our height. So our height is going to be equal to r, because if you think about what this is, if we have these pieces standing straight up, then the distance from the top to the bottom is going to be the radius of our circle, because it's from the edge of the circle, which is here, to the center, which is right here. So our radius is going to be the height. Now, in terms of the length of this rectangle, it's going to be equal to pi times r, because it's going to be equal to half the diameter, or half the circumference of the circle. Because if you think about it, if we take the blue pieces in the circle, they account for half of the circumference total, right? We have a length here, we have a length here, a length here, 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 and so on. And that is half the circumference of the circle. So we know that our circumference of a circle is equal to 2 times pi times r. Now, if we take half of that, then we can just cross off the 2, because we can just divide that by 2. And when you divide it by 2, these cancel out, and that's just equal to pi r. So this length is half our circumference, which is pi times r. And now if we use that inside a rectangle and multiply the radius by pi times r, which is half our circumference, that gives us pi r squared. All right, so now we're going to do a review question where it asks us to find the area of a circle based on the circumference. If you want to try it, I'll give you a few seconds to pause the video and then I'll explain the answer. So the correct answer to this question was 111.6 centimeters squared. And it says centimeters, but I made a mistake. This should say centimeters squared because we're talking about area. So the question says, if the circumference of a circle is 37.2 centimeters, find the area of the circle. Use pi equals 3.1 and express your result to the nearest tenth of a square centimeter. Okay, so let's make a game plan for how to find the area of the circle, because that's essentially what the question is asking. So we know that the area of any circle, A, is going to be equal to pi r squared, because this is our formula to find the area. So in order to find the area then, there's one other value we need. We know what the value of pi is, but we need to find the value of our radius, because we can't find the area without the value of our radius, because we have to do r squared in it. So in the question, it doesn't actually tell us the radius of the circle. The only other piece of information it gives us is that the circumference of the circle is 37.2 centimeters. So we have to be able to figure out what the radius of this circle is based off the circumference. Otherwise, there's no other way to solve it. So you know you have to use this 37.2 in order to find the radius. So here's how you would do that. You know that the circumference of the circle is going to be equal to pi times d, where pi is just pi. Remember, that's a constant. And we're using 3.1 in this question as the value of pi. And then d is our diameter. So if we can find the value of d, because we know what the circumference is, then we can also find the value of r, which is our radius. Because remember, the radius is always going to be half the length of the diameter in any circle. So let's find the value of our diameter. So our circumference is 37.2 centimeters, and that's going to be equal to pi times d. So now if we divide both sides by pi, right, because you're multiplying d by pi to get 37.2. So if you divide that by pi, these cancel, and so 37.2 divided by pi is equal to 12. So 12 is going to be our diameter. Now, if you plug this into your calculator, and you got a number that's slightly lower, like 11.9 something, that's because you didn't use 3.1 as your value of pi, right? You might have hit the pi button on the calculator and it might have given you 3.1415 something. And if you divide it by that, you're going to get around 11.9 something. But in the question, it specifically says use 3.1 as the value of pi. So this is something that you have to be aware of in questions, that you have to actually manually type in the value of pi that it gives you in the question if it specifies. All right, so 12 is equal to our diameter then, because 37.2 divided by pi is 12. So since 12 is our diameter, then our radius has to be equal to 6. Because remember, our radius is going to be half the length of the diameter, and 6 is half of 12, so radius is 6. So now that we have the radius, we can just find the area, right? Because that's what the question is asking. Because our area is pi r squared, so there's nothing else we have to find in order to find the area. So now let's plug that into the equation for our radius. So our area is going to be equal to pi times 6 squared, because 6 is our radius, and we can simplify this a little bit more. Area equals pi times 36, because 6 squared is 36, because that's 6 times 6. Or you can write this as 36 pi, and then when you multiply this out, 36 times 3.1, because we're using 3.1 as pi, then that gives you 111.6 centimeters squared. And in most math questions, you would have to label this as centimeters squared, but in IMLEM questions, you don't have to label it. You could just write 111.6 and your answer would be correct. And I would advise you not to label it when you're specifically doing IMLEM, just because they'll actually take the points away from you if you label it incorrectly. All right, so we're actually going to talk a little bit more about area because MEET 4 specifically focuses a lot on area of circles. And some questions will have shapes inside of shapes using circles. So you'll actually have to know how to find the area of those. So let me give you an example. So in this question below, it says r equals 3. The outer shape is a square and the unshaded region is a portion of the circle. Find the area of the shaded region, use pi equals 3.1, and round to the nearest tenth for your final answer only. So we have this nice diagram over here. And essentially the question is asking us, what is the area of the shaded region of this diagram, right? So the shaded regions, of course, are here, 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 and here. So the way to go about doing this is you have to think about the diagram in terms of shapes you already know, right? So you might not know how to find the area of a shape that looks like this. But what you do know is how to find the area of a square, how to find the area of a rectangle, of a circle, of a trapezoid, right? You know how to find the area of all of those shapes. And so you can use that in order to find the area of special shaded regions, which might not look like any immediate shape, but you can just use that in order to find the area of those regions. So let me give you an example with this question. So I break this question down into two different parts. So I have the shaded regions and the unshaded regions. But instead of thinking about it like that, I think about it as I have a square and I have 3/4 of a circle. So if I think about it that I have a square and the entire area of the square is shaded in, and then on top of that, I have 3/4 of a circle, which is unshaded, that makes this question a whole lot easier. Because then if I think about it, I can say that the area of the square, which I'm going to call AS, minus the area of this 3/4 of a circle, which will do 3/4C, minus the area of 3/4 of a circle, that's going to give me the area of the shaded region. Because whatever's left over is going to be what's shaded, right? So now I can use this in order to find the area of my shaded regions. First by finding the area of the square, then the area of 3/4 of the circle. So first let's find the area of the square. So the area of any square is going to be equal to side squared. Because if you multiply one side by another side, because they're both equal, that's going to be the area. So in order to find this area, I need to find the length of one side. Well, I can do that using the information given in the question. So the only two numbers it gives us is that pi equals 3.14 and r equals 3. So this part, pi equals 3.14, isn't going to be useful because the area of a square has nothing to do with pi. But we can use this r equals 3 in order to find what the side length of this square is. So since the radius equals 3, and this 3/4 of a circle is inscribed inside the square, which means it's touching all the edges, then we can say that the side length is going to be 6. And the reason why is because if you think about the radius, which is the length from the center of the circle to the outside, you can draw a radius right here from the center to the bottom of the square, r, and that's going to be 3. And you can also draw a radius here from the center to the top of the square, which is also going to be 3. And when you combine those two lengths, that gives you 6. So that, therefore, the area of the square is going to be 6 squared. And that's going to be 36. All right, so now we have our area of a square. So now we have to subtract from that area the area of 3/4 of a circle. So in order to do that, we really just have to find the area of the entire circle, imagining that the circle extended to become like one whole circle. And then you just multiply that by 3/4 because we only have 3/4 of a circle here. So the area of a circle is equal to pi r squared. And since it gives us r in the question and it says use 3.1 as pi, we can just plug these values in and get area equals 3.1 times 3 squared, or 9 times 3.1, which is pi. We have to use 3.1 as the value of pi. And then when you multiply that out, that gives you 27.9. So the area of this circle that we've drawn is going to be 27.9. But we have to find the area of only 3/4 of that circle because this part of the circle doesn't actually exist. So if we find the area of 3/4 of the circle by multiplying 3/4, which is 0.75, if you like to think about it that way, by 27.9, that's going to give us 20.925. 20.925. All right, so the area of the square is 36. The area of 3/4 of this circle is 20.925. And so now if we subtract that, we do 36 minus 20.925. That gives us 15.075 as our final area of the shaded region. So let me write that out. 15.075. And then it says round to the nearest tenth for your final answer only. So if we round to the nearest tenth, which is this digit, it gives us 15.1. All right, so now I have a review question about special shapes where you have shapes inside shapes and shaded regions. If you'd like to try it, I'll give you a few seconds to pause the video and then I'll explain the answer. So the correct answer to this question was 1.2 inches. So the question says the side length of a square in the figure below is 2 inches. The arcs are all 90 degrees arcs of circles with a radius 1 inch, and the small white circle has a diameter of 1 inch. How many square inches are in the area of the shaded region? Use pi equals 3.1 and round your answer to the nearest tenth. Okay, and I just realized I made this mistake earlier too. This is supposed to say inches squared because we're talking about area. Okay, so cool. So earlier when I was explaining how to do these questions, I said you don't want to think about the question in terms of you have a shaded region and you have an unshaded region. You want to think about it in terms of shapes because we know how to find the area of a circle, of a rectangle, a square, and so on. So if we can break this question down into only those shapes, we can use that in order to find the area of this shaded region. Right, so I'm going to think about this question in this way. I have this square that's surrounding the entire thing, and this square is shaded in. And on top of that shaded in square, I have 5 unshaded regions, which I'm going to call region 1, region 2, region 3, region 4, and region 5. So these are my 5 unshaded regions. So if I can find the area of the square and subtract the area of the regions 1 through 5, right? And I'm just going to write it like this, but you'd have to add them all up. So the area of regions 1 through 5, that's going to give me the area of the shaded region, A of SR. Okay, so cool. So now my job then is first to find the area of the square, because that's the first thing that comes in this formula I wrote. So it says the side length of the square in the figure below is 2 inches. So that's pretty simple. We know that the area of a square is going to be side squared, right? And since we know that the side is 2 inches, the area is going to be 2 squared, and that's going to be 4. Okay, so the area of the square is 4 inches squared, I mean. All right, so now we have to subtract the area of the regions 1 through 5. So we can't just find the area of all these regions together, We're going to go through them one by one and figure out what the area of each of them is. So first, let's start with the area of region 1. So region 1 is pretty simple. It says the arcs are all 90 degrees arcs of circles with a radius 1 inch. So this arc is 90 degrees, which means it's 1/4 of a circle, right? So if we use the circle formula then, A equals pi r squared, and multiply that by 1/4, then we can find the area of region 1. All right, so the area of the circle is going to be pi times r squared. And since it says that the radius of these arcs, right here, the arcs are all 90 degrees with a radius of 1 inch, we can say that the radius is 1, and 1 squared is just 1. So pi times 1 is just pi, and then times 1/4. All right, so we get area equals 3.1 times 1/4, right? And then you'd have to plug this into your calculator. And remember, we have to use pi equals 3.1 because it says so in the question. And so if you multiply the value of pi by 1/4, then you get 0.775. All right, and I'll just write that out. So the area of shaded region 1 is 0.775. Now, something we want to keep in mind is we're not going to round to the nearest tenth until we get our final answer. I know it says round your answer to the nearest tenth here, but that only applies to your final answer, because sometimes when you round before you get your final answer, you can actually get the wrong answer if the rounding has too much of an effect. So we're going to leave it as area of unshaded region 1 is 0.775 inches squared. All right, so now let's go to find the area of unshaded region 2. Now, I know a lot of you who are going through this question with me would say, why didn't you just do them together? Because I was just trying to make a point that this is the best way to go about questions, especially if all the areas are different. The area of region 1 and region 2 are going to be the exact same. They're both quarter circles with a radius of 1 inch. So we can just say the area of unshaded region 2 is also going to be 0.775 inches squared. So I'm running out of room here to write. Okay, so I'm actually going to erase some of this stuff here so I have a little bit more room to write, but I promise I'll write it back later. And up here, I'm just going to write the area of our square equals 4. All right, so cool. So now we have unshaded regions 3, 4, and 5, which we have to find the area of. So we're going to go to unshaded region 3 next. So that's going to be the area of a circle, right? Because we just have a circle here, and it says the small white circle has a diameter of 1 inch. So our area is going to be pi r squared, because that's the area of a circle. And since it has a diameter of 1 inch, then the area of the circle, or the radius of the circle, I mean, is going to be ½ an inch, because the radius is always half of the diameter. So therefore, we have pi times 1/2 squared, and 1/2 squared is 1/4. So that's going to be pi times 1/4. And we already did this math earlier, right? We did it over here. And that's also going to be equal to 0.775 inches squared. All right, so now we have unshaded regions 4 and 5. So we're going to find them individually. I know that they're going to be the exact same, but it does help a little bit to think about it as individual regions and just say that the areas are the same after you find the area of one of them. All right, so the area of shaded region 4. This is the most difficult one that there is, right? Because it's not just a shape that we know. We can't say, oh, it's this much of a circle, or it's a full circle like we did with region 1, 2, and 3. But what we can think of it is, or what we can think of it as, is the area of one shape minus the area of another shape. And this is where these questions get a little bit tricky, but stick with me. If we think about it like this, where we can make a square, right? Because this region extends from here all the way to here, right? So we just made a square. And this square that we just made has a length or a height that's half of the height of the big square, right? So this is a height of 1, and we have a length of 1 as well, because it's half the length of the big square. So we just made a square here that's a 1 by 1. And inside the square, and just imagine this is shaded in because we're not worrying about region 3 here. This is just, we're drawing shapes to think about region 4 in terms of shapes we know, right? So inside of the square then, we have this unshaded region. And inside, or in the part that's not the unshaded region, is 1/4 of a circle. Do you see it? This section right here, and I'll just draw around it, is going to be 1/4 of a circle. So if we subtract this 1/4 circle from the area of this square that we just drew, that will give us the region, or that will give us the area of unshaded region 4. All right, so now let's find the area of this square that we just drew. It's a 1x1 square, so that's pretty simple. If we square the side length, which is 1, that gives us our area equals 1 inch squared. All right, so now if we find the area of 1/4 of a circle, which has a radius of 1 inch, because remember, when we go from here to here, and I know it's a little bit hard to see, so I'll draw it in a different color. When we go from here down to here, that's a radius of 1 inch. All right, so now if we do 1/4 of a circle, area equals pi r squared times 1/4, then we get pi times 1, because r squared is 1, and then times 1/4. And we know from the past, when we multiply pi times 1/4, that gives us 0.775 inches squared. So now if we subtract the 0.775, which is the area of this 1/4 circle, from the area of this bigger square that we drew, we can find the area of this unshaded region 4. So 1 minus 0.075, I'm going to write this as A4, because the area of unshaded region 4 is going to be equal to 0.225 inches squared. All right, and then the area of unshaded region 5 is going to be the same as the area of unshaded region 4, and that's also going to be 0.225 inches squared. All right, so now our final job is to use these numbers that we came up with, right? Because we found the area of unshaded regions 1, 2, 3, 4, and 5. And I'm actually going to just erase some of this stuff here so it's easier to see. So we found the area of unshaded regions 1 through 5, and we know that the area of the big square is 4. So if we subtract these 5 areas from 4, so 4 minus 0.225 minus 0.225, because we have 2 of those, and then minus a 0.07 or 0.775, 0.775, and 0.775, which I'm just going to write as 3 0.775s, or 3 times 0.775. When we subtract that and then we round that, our final answer is going to be 1.2 inches squared. All right, and just to review what we've learned this lesson, so we started by learning about circles, which are a set of all points equidistant from one point, which means that when you take the center point, the distance to any part of the edge of that circle will always be the same. So that distance we call the radius. It's the distance from the center of the circle to the edge. And it doesn't matter where on the edge you go, because that distance will always be the same, because that's the entire point of a circle. So that's what we call the radius, and that we label as r. So then we learned the diameter, which is a capital D, is the length of a line that runs across the circle through the center of the circle from one edge to another edge. And the diameter is always going to be twice the radius, because the radius is the distance from the center to an edge, and the diameter is the distance from an edge to an edge. So that's always going to be twice the radius. And then finally, the circumference is the distance around the outside of a circle, and we label that as C. You can think about the circumference as the perimeter of the circle, but we have a special name for it. All right, so then we talked a little bit about circumference and area. We learned some formulas. So the circumference of a circle is going to be 2 times pi times r, or pi times d, where d is our diameter, r is our radius, and c is our circumference. And then we also learned what the value of pi is. Pi is just an irrational number. It's what we call a constant. It's just a number that we have to use in these formulas, and it's about equal to 3.141. In a lot of questions, they'll give you a value of pi to use, but if they don't, you can just use 3.141 and round to whatever they tell you to for your final answer. And then we did a practice question where we found that if the diameter of a circle is 4 centimeters, then the circumference is 12.56 centimeters. Then next we talked about area, where the area of a circle is pi times r squared. So we have to use radius in this case instead of diameter, which is easier in circumference. And then we did a practice question with that where we found that the area of a circle with a diameter of 4 centimeters is also 12.56 centimeters squared. Then we did a review question where we found the area of a circle based on the circumference, which was 111.6 centimeters squared, and I labeled it incorrectly. All right, then we continued to talk about area because MEET 4 has a lot to do with area. And we did this practice question where we thought about this figure in terms of shapes we already know, where we thought about it in terms of a shaded square and 3/4 of a circle that's unshaded on top of that. And then we found the area of the shaded region using subtraction. And then finally, we did a similar concept where we found the area of the shaded region here by thinking about it as regions 1, 2, 3, 4, and 5, and then an entire square that's shaded in. And we found that area to be 1.2 inches squared. All right, so that's all for today's lesson. I hope it was helpful, and I'll see you next time.